Welcome everyone to the webinar about the demolition of 5 iconic high-rise buildings in Denmark. I'm Marlene Thorman and I am Business Development Director of Sustainability and Circular Economy in the office in Denmark. I will present a project about demolition in Denmark. And I will say, if you have any questions, you're very welcome to write them down in the question box, and then we will take all the questions in the end of this presentation. If you are interested in the presentation, you can have it in the handout box afterwards. I will start by introducing myself and my team. I am placed in the Earth and Environment Division in WSP in Denmark, where we have a team which is specialized in demolition and reuse of materials. We are approximately 12 people working with these services, which also include the mapping of contaminants and mapping of resources, plan how to use the resources afterwards, tender materials for demolition, health and safety, and so on. We are also closely connected to the building and property division as well, so we have a close collaboration. In this webinar, I will have a brief description of the site and the history of the building who is demolished, and talk about why the building is needed to demolish. That's I can say it's because of the contaminants with the PCB. What have WSP been doing at this project? Tell a little bit about the selective demolition and some key takeaways, and then in the end you all are very welcome to to write the question down, and then I will answer all as good as I can. The 5 high-rise building is a place in a city called Brøndby, who's lying near the capital of Denmark, Copenhagen here. In this city of Brøndby live about 34,000 residents in all, but more or less 25% of these people live in the area of Brøndby Strand, which is the name of the area where these 5 high-rise buildings are located. Here we have the area seen from the crane, 65 meters above ground. You have the high-rise buildings here. There are 12 of these. And then there are 66 buildings with 4 floors, and then 8 terrace house building with 2nd floors. So it's quite a big area where these buildings are located. The area is built between 1969 and 1974, and therefore it was a plan that it is a plan that the whole area here needs to be renovated, and it actually was the plan from the beginning that the whole all 12 high-rise buildings needed to be renovated. But when the plan began and some sampling was done, it was found out there was a lot of PCB in the 5 easternmost high-rise building, and as therefore was not possible to renovate, and it was decided to demolish those 5 buildings. the rest of the 7 high-rise building will be renovated, and the same as the lower houses. All the green areas will also be developed and renewed. So it's a long plan for this area. This contract WSP have been involved with since 2017 and is still ongoing. And there actually are 3 clients in these 5 buildings. There's in Danish, Brøndby Almennyttige Boligselskab og Postfunktionærernes Andelsboligforening og Bovest, which all 3 are some housing association with a lot of people living in it. For a lot of you probably know the problem with PCB. It has been forbidden in Denmark since 1977, but it's used in a lot of building materials. Elastic sealing is one of the primary used products, and it also was the one in these buildings which have been used a lot of PCB in. Also the thermal windows and in paints. It also been found under the floors where the ceiling had been. It looked like it was almost filled out in under the floors. It's a toxic, a low acute toxicity. It's been can be absorbed by contact, inhalation, and by food, and it's probably carcinogenic and a hormone disruptor. So it's not a good thing to have in the building or be have in contact with. Before we got the contract about the demolition, we have been involved in sampling in the apartments. And what you see here is the sampling with the indoor climate in nanogram PCB per cubic meters. You have imagine the high-rise building. You have the floors here, and then you have the apartments numbers out here, and then in this apartment where it's not have been sampling, it's the blue one, and then you have the 3 colored here that it's colored how it's the recommendation from the Danish health authority. If you have a concentration for 3,000 and above, you need to do something really quickly. And then you have a middle one with from 300 to 3,000, and then underneath 300. In here you only have 1 apartment. You should plan for something. And what you see here is that it's really a lot of high concentration of PCB in the indoor climate, and the concentration was coming from it's a tertiary concentration from the surroundings of the ceilings, from the outdoor elements and from around the windows, where we had found up to 230,000 milligram per kilo PCB. We tried to see if we could do anything else than demolish the buildings. So we tried to make a pilot project where we the plan was to seal an apartment and try to heat it up and to make the PCB evaporation happen faster. but it was not possible to control the heating and how the PCB was evaporated. So therefore, it was decided to demolish the buildings. Here you see a part of the area. The black ones here are the high-rise building, the 5-1, who is demolished. And then you have 2 bridges here, who always has been demolished. And then there is some smaller parts here. So it's over quite a big area, and it's always very closely close with other buildings where people still was living in. And then you can say why it's only the 5 building and not all 12, and that's because the oldest buildings there we found PCB in high concentration, and actually in the 5th building we found here on the 12th floor and upwards, it was stopped using PCB as in the ceiling and so on. So it's not that high concentration, and therefore the last 7 high-risk building is not being demolished. As I mentioned before, WSP have been involved in the projects in 2011 by sampling and testing for PCB. And since 2017, we've been a part as an expert for demolition and engineering and environmental engineering for how to plan and do this kind of demolition. Now I have talked a lot about why the building needed to be demolished, and now we'll try to tell about how we are doing it. The building is it's a selective demolition, which is a gentle separating of the buildings. So it's not that much dusting and so on. You have a very it's a controlling, very controlled demolition, and the buildings are first of all emptied for everything: inventory, kitchens, heating, installations, and so on. And then necessary remediation is done, for instance, for asbestos. And then you have built up the scaffold, and then afterwards the 65-meter high crane lift elements down one by one. You actually see it here. You can see there's a door hole in here, so it's an inside wall. The crane is lifting down, and then it's placed on a truck, transported to the Netherlands, where they have a facility where they can bake or heat up the elements, so the PCB will evaporate faster, and then it's crushed down and used instead of natural resources as sand and gravel. Here we can see a closer look of the construction site. It's the same, more or less same picture, but I took this with as well because you over here see where the first building was placed. It's down, and now it's only it's not a hole, but almost a hole where the building was. Then you have the second building here, where it's down. I think it's approximately the 6th floor. It has been down in here, and you have the excavators, 2 excavators here, and it's have a hammer on, and then it knocks down in the elements. and then the crane came and lifted down here to this truck, and the truck is lifting the element up to the trailers. You also have here containers for a different type of waste. Around the buildings you have a scaffold, and it's netting and plastic on. That's to avoid dust spreading and smaller parts here from the elements and the knocking down, so it will not fall all over, so it's controlled. Yeah, the key challenge, you can say it's a challenge that you have so high building which is deeply contaminated with PCB, and it's also located in a densely populated area. So it's a really good need. It's a need for planning and for good dialogue with the landlord and municipality and the residential association, demolition company, and so on. And that is in the beginning of the project and in the planning, but also now when the project is ongoing. But some of the key takeaways we can take with this project is that thinking circular, we have been able to utilize a large amount of concrete, even though the contamination of PCB. There is approximately 30,000 tons of concrete, PCB contaminated concrete. And here we have solved it by transporting to the Netherlands because we don't have this kind of facilities in Denmark. But it has started innovation ideas of how to build some kind of facilities, maybe not this big, who can take 30,000 ton of elements, but smaller ones, so we can reuse more materials in other buildings or crush it down, so we can get rid of the PCB. Throughout the whole project, we have been very focused on the health and safety, and that of course includes the safety for the workers on site, but also in the surrounding area and the residents. There have been, as I mentioned before, people living there and children playing, not in the construction site, of course, but nearby. So it's been very important that we have it under control all the time. And I mentioned it before also, but the planning and a close follow-up together with an open and honest dialogue with the housing association, but also with the demolisher, so we can solve what kind of problem which is coming in this kind of problems. There have been no complaints from the neighbors, and there have not been a spread of contamination in the area. So I think it is an exciting project, and we have also learned a lot about it in the whole this more or less 10 years we have been in the project. So I don't know if there is any questions.
Thank you, Marlene, for your fantastic presentation. So just some housekeeping items before we get going for the Q&A. The presentation slides are available to download as a PDF from the handout box, and also you can continue to ask questions in the question box on the control panel. I will start with the first question. I think you covered it, but how will the separation of materials contaminated with PCB be done? Is it before, during, or after the demolition?
it will be what could you say, more or less throughout the whole part, because when you separate the elements, you separate where the sealant are. So if it's fell down, you take it there. Otherwise, it's handled in the Netherlands.
Thank you. Have there been any mapping of resources prior to the demolition?
Yeah, there have been some kind of mapping where you have found out about how much wood would there be, how much concrete, and so on, but not a specific mapping as we use now, where we'll go in and do a more separate mapping. And there we can say that it's an older project, so we have learned a lot, luckily, from 2017 until now.
Thank you. You mentioned heating of elements and a pilot project with heating an apartment. Do you have any project where there have been a reduction in PCB after heating up the buildings?
Yes, we have done a project in a school where we have heated up a part of the school, where we actually saw that the PCB was there was less PCB afterwards, and then the school could be used as it normally would. Otherwise they needed to demolish that part of the school because of the PCB in it. We also have done it in a kindergarten with a good result as well.
Thank you. Sorry, is there anything else to mention?
No.
Okay, perfect. This project started in 2017. Do you think there would be even more focus on reuse of materials if the project has started now in 2022?
Yes, I think so. I actually had a meeting today out there where we talked about, now we are in building 4 and 5. Was it possible to use some of the concrete not contaminated with PCB in the surroundings or as a outdoor wall? So the focus has changed. So it's possible to reuse other things, and I think if we have the knowledge as we have now, back then, it might have been more possible to reuse more. But because of the PCB, it's quite difficult, of course.
Thank you. So we don't have additional questions, so we're a bit early today, but thank you very much, Marlene, for a fantastic presentation, such an impressive project, and including circular economy. So thanks again, everyone, for joining us, and please feel free to follow up directly with the presenter via the contact details shown on the screen. So have a good day, everyone.
Yes.
Thank you so much.
Good day. Thank you.